Hello everyone, so in this video we are going to learn about multi-head attention. So we'll look at the visualization and everything right from the scratch. Okay, so let's again, as usual, let's start with an example and fill in the blanks question. We have how are, and then there are three options: how are sleep, how are London, and how are you. Obviously if you are, if you have read this sentence, the answer is you, right? The option C. Now this was not the point. The point was basically how are we going to make sure we are able to do multi-head attention using this example. How are we going to fill this particular blank? So the way it is done is, first every word is taken and then converted into a vector, right? So how is represented by this vector, the word are is represented by this vector, and the dash, which is the blank, is represented with this vector. Okay, so what to do again, if you remember, in our attention mechanism video, we had said that every word is represented by query, key, and value. And how many words are there right now? Here are three words, right? How, are, and dash. Dash is also a word for our to say example right now. So which means you are going to have, for every word, for example, let's say the word is how, you are going to have one query vector for the word how, one key vector, and one value vector, right? So these are just an example. Okay, these are just examples, you don't have to worry. So how to get those vectors, right? We have said that, okay, we'll need the vector for all the words. So how to get this? Obviously, we have seen this in the last video. So the way we do it is, we take the query matrix over here. Okay, we will see what those query matrix are, and we take the word embedding. Word embedding is something we have seen over here. These are the word embeddings for all the words. You just matrix, like put it in a matrix. Okay, so you will have 1 and 2. So as you can see, 1 2. So you'll have this value over here, and this value will come over here, and this particular value will come over here. Similarly, this particular 0.78 will come over here, and minus 0.43 will come over here. Same for this one, it will come over here, and this one will come over here. Okay, once that is done, what you're going to do is, you're going to get your query vector by whatever the word embedding matrix just we have that we have just created, this matrix that we had created right now. This will be taken, and we'll have one randomly initialized query matrix which will be fine-tuned during training. Same thing for the key vector, and same thing for the value vector. Okay, so let's start with the example how to create our, let's say, the query vector or query tensor, you can say. Okay, so as we said, we need a query matrix for that, right? So for query matrix, this is a random matrix. Okay, so let me just write it over here. This is a random matrix. It will be learned. Okay, it will be learned, right? So these are random values. Okay, same thing for the key matrix. Why? Because again, this also needs to be learned, and same thing for the value matrix, this also needs to be learned. Now in this example, we are taking 2 cross 20. Okay, why 2? This is easy to understand, because our embeddings is 3 cross 2. 3 cross 2. Why? Because there are three words, so, and each word is represented by two numbers. Okay, so that's the logic for this one. So let's get the query vector. How we are going to get the query vector, we have already seen. The way we get the query vector is multiply query matrix into word embedding. Now I have put this over here. This is the query matrix, and this is the word embedding over here. Why I have done like this? Why I have swapped it? So that I don't have to do transpose, because we have already done it in the last video. So you are having something that is 3 cross 2, that is being multiplied by 2 cross 20. So your answer will be something like this. Okay, that will be 3 cross 20. As you can see over here, it's 3 cross 20. And each word, this is the query vector for the first word, that is the word how. This is the query vector for the second word, which is are, and this is the query vector for the third one, which is dash. Okay, same thing for the key vector. I'm going really fast over here because we have already seen this, and it's easy to understand, right? So this is your key matrix that we have already seen, and this is your word embedding, which was same as the last word embedding. This word embedding over here, this one, as you can see, this particular word embedding is the same as this particular word embedding. Why? Because the word embedding does not change, it's fixed. What changes, I mean, obviously this one also changes, but due to the changing in the embedding layer, but this is out of the scope right now. In the next series, in the transformer series, we'll see that. Okay, but this matrix is, again, this is what we learn generally, so this will continue to change. Again, 3 cross 2 into we have here 2 cross 20. What you'll get? 3 cross 20, right? So you see over here, it's 3 cross 20. Again, this is the key vector for, this is the key vector for the word how, this is for r, how, this is for r, and this is for the dash. Same thing for the value vector, same thing, same story. Okay, now how do we do this. How do we do now here, from here we start multi-head attention. Okay, multi-head attention is what we are going to start over here. We say number of heads equal to 4. So what we'll do, we'll divide the embedding dimension. We will see what this is into number of heads. So first we have to specify how many number of heads we want. So we are saying that in our case we want 4 heads. Okay, so what we do, we will divide all the query vector, key vector, and what to say, your value vector, or a tensor, let's say query tensor initial. So this is what we had gotten in this step, right? Remember, this is value, this is key, and this is query. So this is what we had gotten over here, right? So we took this particular tensor over here, we put it over here, we put it over this part here, we put it over here. And now what we are going to do, we are going to divide this into 4 heads. So obviously, so you can see over here, it is the first, this is for the second, this is for the third. These are dimensions. This is for the first dimension. Here this dimension is for the word, this dimension is the embedding dimension. This is the first, this is the second, this is the third. You see over here, 3 is there, 3 is there, 3 is there, and dot 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 up to 20. This one is the 20th dimension. So how we are going to do it, we are going to, okay, yeah, so we are going to, what we are going to do, we are going to take this particular initial one, this is till 20, and we are going to divide it into 4 heads. Okay, you can see over here we have divided this into 4 heads, which means some part of it will be head 1. Okay, let me just do it properly. This part will be head 1. Now obviously there are dot dot dots, means there are many over here. So some part will be head 2, some part will be head 3, and then some part over here will be head 4. This is how it is divided. Let's see in the next slide, it will become more clear. So out here you can see these are till 20 numbers. Okay, so this is the query tensor. Okay, the query tensor that we have seen. This is 20 over here, 20. You can see over, you can count also. Okay, 1 2 3 4 5, and so 4 of them. So the red one is the first head. This will become your first head for the query tensor. This second one, okay, here remember, if you remember, wait, just give me over here. Yeah, here is your word how. This is the query vector for the word how, this is the query vector for the word are, and this is the query vector for dash. This way it's the query, and this way were the dimensions, or the embedding dimensions. Okay, so what we did, we took every word, but we took only first 5 of the embedding dimension, and then we created in a head. This one, these 5 over here went over here to the second head. The green one over here, it went to the third head. And then the blue one over here that you can see, this one, blue one, this went for the fourth head. Okay, so this is how we divided. So this is how we divided the query tensor. Okay, this is how we divided the query tensor. And the shape initially was 3 cross 2. Now you will see the shape is over here, it is what, 4 cross, and every so 4 heads from and every head is 3 cross 5, right? So 3 cross 5, 4 cross 3 cross 5. Okay, so this is something that we had over here also, 4 cross 3 cross 5, 4 cross 3 cross 5. Okay, this is how you understand. Now one caution that you need to remember, what is the number of head? We just took it as 4, right? But how do we get it, or how do we make sure it is correct? Well, whatever is the k dimension, initially if you remember it was 20, this should be divided by the number of heads. Okay, this is the number of heads, this is the dimension of heads, d of head is the dimension of head. Okay, the number of heads is 4, which will divide it for 20 divided by 4, it will come 5. So this is how we know this is going to be of 5 dimension over here. Okay, intuitively you could have understood, but I just explained it over here. Okay, so caution is important. So this is how we have already done the query tensor. We know already this is how we did. Same story for the key tensor. You see, for the key tensor. Now one important thing, in the query I have represented it as q of 1. So this initial 1 is the word. So your first word, second word, third word. And here this 1, this 2, this 3, this 4, and this 5 is actually this embedding dimension. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Okay, now key tensor, same thing. This one is word, this one is your embedding, or this one is your key dimension. Okay, embedding dimension. So again, for key I have taken as key, this initial 1 2 3 is your word, and these are your dimensions. This 1 1 2 2, these are your dimensions. So again you can see this entire 5 came over here, it's shown in red. This one is shown here, this one is shown over here, and the blue one is over here. You can see, so 4 heads. Same thing for the value, same story. Okay, so and we have represented it with v. Now if you remember, once we already have the key, once we have the query and value, what we need to do, we need to apply this formula. Now we are going to apply this formula step by step. So we'll keep the formula over here, and you see over here we need the transpose of this, right? So we had the key, so this is the key. You can see over here I have not changed anything. We have the key. Okay, this is exactly what we had gotten up till now. But what we need to do is, this is already 4 cross 3 cross 5. You can see we have already seen that, right? 4 heads are there, 4 heads, one head 1, head 2, head 3, head 4, and each head is 3, to say in the row dimension, you see 1 2 3, and 5 in the to say your embedding dimension, right? This one. Now what we need to do, since we are going to transpose it in the last two dimensions, which means this dimension and this dimension, we are going to make it 5 cross 4 cross 5 cross 3. We are going to interchange these two dimension. Okay, we are going to interchange. So this 3 will go over here and this 5 will come over here. So it becomes 4 cross 5 cross 3. So how it will look? It will look something like this. So what we did, we just interchanged the last dimension. Now it became, first it was, you can see over, it was 3 cross 5. This one was 3 cross 5. Now this is 5 cross 3. 5 cross 3. You can see 1 2 3 4 5, and then 1 2 3 5 cross 3, and same thing for all the heads. Now we have done the this kt, that is transpose of the keys. Okay, now what we need to do, we need to multiply. As you can see, we need to multiply. So this is just for your reference, so that we keep everything in view. So this is for the query, this is the q over here, and this is the k transposed. Okay, this is the k transposed. Now this is, query has not been changed, so it is 4 cross 3 cross 5 only, and key was changed, so now it's 4 cross 5 cross 3. Now these two will be multiplied, right? So when this will be multiplied, you'll get 4 cross 3 cross 5 multiplied by 4 cross 5 cross 3, which means you can see over here this multiplication will happen, and what you are going to get is, so when multiplication happen in 3 dimension, these two need to be similar. Okay, this is what you need to remember. These two needs to be similar, and what you will get is 4 cross 3 cross 3, because over here this one will remain and this one will remain. Okay, I hope you understood. Now let's see for head 1, and then we will just make it it will be the same for other heads as well. So for the head 1, if you remember, again I just kept it over here. This is only for reference, so that it is in front of you. This is the query, and this is the key transpose. Okay, so you take the first head. So this is the q. Remember, all these are starting with q. So this is the query tensor of first head. Query tensor of head equal to 1. Okay, I don't know why it writes like this, 1. Okay, and this is the key transpose of head equal to 1. Once you multiply, this is 3 cross 5 and this is 5 cross 3. What will you get? Obviously you get 3 cross 3. Now I have represented it as m. Why? Because this comes in the middle. We have to do other things as well. Okay, so 1 1. Now here 1 1 1 2, all that doesn't matter. Okay, what matters is this 1 is for the head. Okay, this one is for the head, and obviously it is also shown in red, so you can obviously see, you can distinguish the head. So how can we do for head 2? Simple, you take that query, or to say your query for the head 2. You see query over here, and this is the word. Remember, these are the words, and the second dimension starts from over here, but since the red was till 5, this starts from 6 7 8 9 10. Same thing, you have 3 cross 5. This is the key transpose. This is the key transpose. Okay, and this is finally what you get. Same thing for the head 3 over here, and same thing for the head 4 over here. No story change, same thing. Okay, once you have that, remember, we have found till over here, but we also need to divide it by the root over k dimension. Now what is k dimension? This time k dimension is 5. Why? Because if you remember over here, the keys, let me just go back to the keys before you did the transpose, right? Okay, let me just go back. Key tensor, right? You see, key is having 5 dimensions, 1 2 3 4 5. Now obviously it has to be same to the query dimension. Value dimension can be different, but in this case we have taken the same. But you can see over here, k dimension is equals to 5. This is how we got 5. So let's go over here, 3 4. Let's get the k dimension. So now you can see this is 5. Now you have to take the square root of that. Square root of 5 is 2.236. So obviously we are having symbols over here. You can see this is for the first head, this is for the second head, this is for third head, this is for the fourth head. We have to divide. This is all the value for k into q into k transpose. These are the final results coming out of it. Okay, so now what happens is you divide all of them by the square root of k dim over here. Also divide all of them by the square root of k dim. This is the same value, and what you get is a score. Okay, this is not the softmax score because we still have to, but I have just represented it as s. Okay, s of same thing. First head is represented by this 1 1, this is represented by 2 because this is a second head, this is the third head and started by s3, and this is the fourth head which is started by 4. Okay, now we'll have to apply softmax. As you can see, rest everything we have done, we have calculated this entire thing. Now we need to apply softmax. So remember, these are the heads over here, and what we have to do, we just have to apply the softmax to all of them independently. Okay, and softmax applies along this direction. So if you add all of this after softmax, it will come to 1. Okay, now how you do it, you take this particular head, you apply a softmax. Okay, I have not shown it over here, but you have to apply softmax along this dimension, along, let's put this dimension. And once you do that, you get certain values over here, a1 aw11 aw12 aw13 and so on and so forth. And once you add aw11 plus aw12 plus aw13, you will get equal to 1. Okay, this is what you will get. And same thing for these also, same thing for these also, and so on and so forth. Even for these also, even for some random this also and this also, all of them will come to 1. That's all I'm saying. This is how it happens. And this is 4 cross 3 cross 3. You can already see there are 4 heads and each head is 3 cross 3. Now just keep in mind, these were attention weights. That's why I had said AW. These are attention weights, but we have to multiply it with the value, right? So we'll have to multiply with value. So this one gets multiplied to this one gets multiplied to this one gets multiplied to this, and these are what values. You can see it starts with V. These are values, right? And these are your attention weights. This is AW. Once you do that, obviously what we'll do, we'll get a final tensor that is attention weights, which was we'll see the dimension, into value tensor. And you see attention weights were 4 cross 3 cross 3. We had, these are attention weights, right? There are 4 heads and each head is 3 cross 3, and for these values, it is 3 cross 5. So this is 4 cross 3 cross 5. So here, that's why you can see 4 cross 3 cross 5. Once that happens, what will be the size of the tensor? It will be 4 cross 3 cross 5. Why? Because this one and this one has to be same, and hence these two values will be retained, right? So this is what happened. These two values are retained because these two are same. Okay, this one does not matter, it just has to be same. That's it. I mean expandable, not even same, expandable. So here I'm just showing you the for your analysis and for your visualization basically. So you have 4 of these over here, 4 heads. As you can see, blue head is here, green is here, yellow is here, red is here, and these are your attention weights. As you can see over here, attention weights, and these are your these ones are your value tensor. Once you multiply that, you will get something like this. Okay, these are also these are your final. That's why I have represented as F. Okay, so these are your final, these are all your heads, right? As one is your head, this one is your head, this one is your head, and then this one is also your head. So this is 4 cross 3 cross 5. Once that happens, you need to transpose the first two. So remember, this one is 4 cross 3 cross 5. Now if you transpose it, it will become in the first two dimensions only. It will become 3 cross 4 cross 5, right? So you come over here, you will see 3 cross 4 cross 5. Now what will happen? What was 3? 3 was the number of words. So this is the representation for word how. This is the representation for the word are, and this is the representation for the word dash. That is what is happening over here. That is the final scored vector. So which means these are weighted vectors now. Okay. Now what you need to do? You just need to flatten this. This is a matrix, right? This looks like what? 4 cross 5. If I flatten it, it will become 4 into 5, that's equal to 4 into 5, that's equal to 20, right? Same thing has happened. This again come back to 20. You can see over here, this was the first word, this was the vector for the word how, these are the vector for the, this is the vector for the word are, this entire thing is the vector for the word are, and this is the entire vector for the word dash. dash, you can see over here. Okay, so I think this is the end. Let's see. Yeah, this is the end. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much and bye.